And now let's see how Nmap can be used for host identification. Yeah, so remember that the yahoo.com range we have already processed during the open source intelligence or during the reconnaissance stage. So let's see the net blocks here marked with the blue here, and choose some not really large one in order to identify some live hosts in it. So this is the autonomous system that fully belongs to Yahoo, and this is a relatively small IP range, right? /23, I guess. That is belonging to this AS. So yeah, so let's now let's first identify. Let's first see how the process really works. Let me show how long it could take. Yeah, so if your task is to scan something as large as Yahoo network presence, you of course can just create the file with all these networks. For that you have to copy them as values. That's important because from multi-ego graphs you can copy the same data in different formats. So here let's create network list file. Yeah, and as you might see, this is not the same notion that Nmap is expecting from IP ranges. Yeah, so this is like ranging networks. Literally, we need to range IP numbers. Yeah, so in different sectors of IP address, we have to put different ranges of digits of numbers, not networks. Yeah, so let's so first of all, yeah, let's exclude something that doesn't make much sense. For example, this zero autonomous system should not be here, and everything else is pretty much in line with the public IP addressing traditions. Yeah, so what you can now do with all these networks, you can calculate the networks out of these ranges. Yeah, so it should be something in CIDR format. So for example, this network here should look like this. Yeah, we'll get one more bit from the third sector, and then all hosts of the last one. So these will be basically two class C networks. But to do that for some large networks is really time consuming. What can we do? As a real lazy penetration tester, I use this IP calculator. So this is the tool that allows you to produce networks out of ranges. So it just deaggregates address ranges. So for that we can just use it like this. Okay. And it will generate the same notion of CIDR defined network. Okay, so let's use that for our networks file. This is the command line you will be using a lot, so you can write it down somewhere as a script line or something. So for each network in this file, right, let's let's IP calculate the range out of it, right? And let's filter out the gibberish, the metadata, and then feed it back to the networks file. So now we have the list of networks perfectly applicable to configuring a Nmap scan. So Nmap scan would look like this. Okay, and then saving everything to live hosts. Live hosts, yeah, like this. No, like this. So then outputting all different variants of output to this base name of a file. It will be extended by the file types of Nmap, Gnmap, and XML. Okay, so just to give you an idea of how long would it take to ping this range. Yeah, so we are running Nmap, and we can, in the meanwhile, at any moment press a key on the keyboard and see what happens. So this is the progress of our scan through first block of 496 IP addresses, and we didn't find anything alive yet. Okay, so this is really time consuming. It can give you estimated time of completion for this block only. Okay, but let's see what happens. We can increase verbosity by pressing V, but basically it will increase the amount of information that is sent to the output files. At the console we won't see much information, and by Shift V we will decrease it. Debug, if we use it, will increase the amount of debug information. Now we see host by host operations, and now if we increase even more, we see packet by packet, connection by connection. And I will not risk increasing it even more, but you can do it at home. Yeah, let's decrease it back to 0 and see, we are just going to the end of this first block. Okay, so we have found something. In the first more than 4,000 hosts, we collected, let me see how many live hosts. A lot of them. Okay, so almost half of them is up. Yeah, so we are going through the second block of IP addresses, and we of course can continue like that, but let's just take some small network and then perform all the rest of operations over it. So yeah, let's take this small network here and just nmap it with a sen, and then save everything to the same live hosts. Okay, so yeah, wisely enough, if you try to autocomplete the file name after output option in Nmap, it just doesn't allow you to do that. You cannot, you still can, but in this manner you cannot overwrite the results you already have. Okay, as you can see, this time is much faster. So for two class C networks we have just 33 hosts up. Okay, So let's see how different formats look like. So this output format, as you see, is using this. Okay, and SN, for example, is not always using just ICMP. It sometimes uses other protocols as well to scan. Okay, so in our case with a smaller network, we see that normal output is just starting with all these parameters, and XML is something like that with all the parameters too in a separate tag, right? But everything is going by blocks, not by lines, and it's basically more informative in a way. And greppable format is like this. So let's use greppable format in order to create the list of live hosts. Okay, now let's remove this live host data, we leave just live hosts, and now let's get this live host greppable. Start with grepping out first and the last line, and then cut the IP address out of it. Okay, and now save it to live hosts list. Okay, now we will use that as a configuration parameter for service scanning, of course, and then I will show you what you actually can use the XML format for. And for now, I guess that's it. We have identified live hosts. Let's wrap it up and proceed to service identification and fingerprinting.